So I made you waited for another almost like half an hour. Actually, almost all my friends are still there, but I just came here because I had to do the class. But uh, I will just keep doing this type of businesses a lot because tuition is like one of the way of earning, but we have to have some other ways of income sources. Otherwise, we will just find so much of difficulties. So the best thing is for everybody. So should not depend on with one income plan. Okay, by the way, today we have to do very important lesson, that is thermal expansion, expansion of solids, expansion of liquids, and expansion of gases. My plan was originally to do uh, expansion of solids and liquids all together. Let's see how will it just affect. So before that, I want to ask you one very important thing. How did you feel the lesson we learned in the last week? Very horrible, very terrible, very bad, or what? And how? Hello? Can't hear me? කවුරුත් කතා කරන්නේ නැහැ. Hello?
Yeah.
Actually, whatever we
Whitefoot.
learned in the last week, bit terrible. Then hello? Quite good. Huh? කතා කරලා කියන්න එකෙක්වත් නැහැ වගේ. Very bad. කියන්න බෑ. Hello? නැත්ද කවුරුත්? කතා කරන්න පුළුවන් ළමයි ටිකකින් අහලා බලමු මෙතන ඉන්න. එහෙම උන් ඉන්නවද? Hello, Gauravi, you speak normally. How did you feel the lesson last week? And terrible at all. Gauravi, you are someone who can speak. Just speak and tell
Yes,
me.
sir.
How did you feel the lesson?
Bit okay.
Bit okay means bit hard.
No.
Huh?
Average.
Average means some part hard, some part good. Okay, Sarina. Sarina,
Yes, sir.
how did you feel?
Okay. Average.
Average means what? Somewhat okay, somewhat hard. Ne? Sahas, express in your very wonderful voice.
Well, good enough.
What enough?
Good enough to try some MCQs, so I should say it's good.
Good. Okay, great. So now it's all about just a recap of the last week, because some of the students told me that it is kind of like midway, like kind of good, kind of bad. One thing, so temperature scales we learned. No? So the conversion, we learned something called in terms of the measuring instrument of temperature measuring instrument, that means the thermometers, we have to go for something called lower point, but and higher point, right? In terms of the lower point, we normally take it like 0 degree Celsius, and for this one 100 degree Celsius. So any change occur between any in normal temperature thermometers, we have what? This type of rising liquid column. But I told you very thermometric properties, likes of change of resistance, change of potential difference, change of color, change of volume, change of pressure. There are many more variabilities are there. But here the importance is, so whatever the, sorry, is the higher fixed point and lower fixed point. Lower fixed point. Any other, because you will divide this into 100 equal divisions. Any other thermometric property. It can be a resistance R0 to R100, R0 to R100 at here. We don't know. At 100 means 100 degrees Celsius. So, if you want to find out this temperature theta in Celsius, here it will be replicated with any R you don't know. Only thing is you have to get the ratio of this height to this total height. What is it? It is going to be theta minus 0 divided by 100 minus 0. The ratio for this length. Here the ratio for this length is R minus R0 over R100 minus R0. You have to equal these two. R minus R0 over R100 minus R0 equals to theta minus 0 divided by 100 minus 0. It is a very simple equation. I can remember some of the students told me that this is so hard. Was that so hard? අමාරුයිද? නෑනේ. ඊයදී අමාරුයි කියපු දෙන්නම අද නෑ. ඒ කියන්නේ මේ පොඩි ඉක්වේෂන් එක තේරුම් ගන්න බැරුව. ඕක ඉතින් හැම ලෙසන් එකක්ම ස්ටාර්ට් එකේදී වෙනවනේ. හැම ලෙසන් එකක්ම ස්ටාර්ට් එකේදී එකෙක් දෙන්නෙක් ඉන්නවා වැට උඩ. උඩ පටන් ගද්දිම තේරෙන්නේ නෑ. මතකයි නේද? මොකද්ද මේ? සර්කියුලර් මෝෂන් පටන් ගන්න. 8ක් එකපාර මිස්සින් 8ක්. කොහොමද? එකපාරට අයියා ඇටදයි එන්නේ. හරි. Okay. So that's it. Today I want to teach you something really important. I told you that I was planning to teach you that part. I'm again going to teach you the same thing in like 3 weeks from here. That thing is calorimetry. Today I'm going to give you some small kick start for that part, because that's the base and core of this lesson. Core. If you don't know the core, there will be a big problem. Okay. Here. Write this thing. Exchange of temperature. Exchange of heat. Sorry. Exchange of heat due to change of temperature. Due to change of temperature. If a mass of M there, at the beginning, the temperatures can be considered like theta 1. And the next one is, you can add or subtract, so remove heat amount, certain amount of heat. This heat will make the temperature to theta 2. If you add, it will increase. Right. I will teach you this in detail in calorimetry. Today it is not about in detail. I'm somehow going to explain you what is happening. Here actually for the condition I mark it like X. I mark this condition like Y. For the condition X, particles are like this. These particles may oscillate. So the particles are like vibrating. Now the thing is, when you add more temperature to heat to this one, actually heat energy, the temperature heat energy, these particles may vibrate now faster, more violently. You add more heat energy to this one. So this one would oscillate even faster with the wide radius. Okay. Now you can see the particles are vibrating like so violently. Before like this, now like this. Okay. This vibrating particle, each particle absorbs certain amount of energy, certain amount of heat energy. So the other particle absorb according to the amount of change of temperature. So you can see the matter is made out of particle. So when it accumulate more particle, that means more mass is there. So as a result, the amount of particle energy absorbed or released depending on with number of particles, and the mass is directly proportional to number of particles. So when more number of particle increase, mass increase. So directly amount is directly proportional to mass. This is again directly proportional to the change of temperature delta theta. Change of temperature delta theta. So you can come up with the common answer here, proportional to m delta theta. To remove the proportionality, you have to put certain proportionality constant. The proportionality constant is going to be m c delta theta. This is what the proportionality constant. Proportionality constant. Okay. And I want to ask you one single thing from you. Sorry. By the way, today for that session, what is that? 1 year fast track program. A new student called Malsi joined. Are you there, Malsi? Okay. ඉන්නවද? Malsi හිටියා නේද? You gone already? ඉන්නවද? ගිහලාද? Let me check her. Oh, she has gone. Okay, by the way. Okay, so I got a message that saying something like Wi-Fi data or something. Okay, by the way. So they actually thought of the fast track like, oh my God, teaching so fast. No, we teach really slowly and the students really capture everything. Again, හැමදේම capture කරගන්න පුළුවන්. We finish entire force lesson today. Force කියන මුළු lesson එකම දීලා ඇද්දා. හැබැයි හැම ළමයාටම තේරෙන්නේ. ඉතින් so we have the recordings. කවුරු හරි කෙනෙක්ට miss වෙච්ච lesson එකක් තියෙනවා නම් ඒ recording එක කියලා ඉල්ල ගන්න පුළුවන්. හැබැයි අපි charge එකක් ගන්නවා for our regular students. For visitors, it will be one recording will be like 2,000. One recording means 1 day. For you guys, you can pay 1,000 and get the recording. So in the next week, we are planning to do what is it? The law of conservation of momentum completely. And the next very day, we are going to do like work, energy, power completely. And like circular motion, rotational motion completely, and hydrostatic completely, and complete entire mechanics with A-level type of exam questions altogether. මේ වගේ අර බබා කර ඉන්නේ නෑ එච්චර වෙනස. Right. So here it is. U equals to MC delta theta. Right. Don't write any note because I will provide note in the 21 lesson, that is in the thing called what is it? Calorimetry. So today it is not calorimetry. I'm going to give you some kickstart. So copy these things. All level thing. I'm just reminding because this is the base and this is the heart. You may have to have a kind of earlier practice. Have you copied this? Copy කරගෙන ඉවරයිද? ඔයාලා copy කරගන්න එතකම් වතුර ටිකක් දීලා එන්නම් පට්ටි ගහයි. ආපු ගමන් එහෙම්ම ක්ලාස් එකට ආයි. Copied the thing. Hello. This part. Let me turn off the light then. Can you see it? Can you see it? Not that light. Can you see it? Okay. Give me 1 minute. Okay. So whatever the thing called specific heat capacity is there. What is specific heat capacity stands for? What the specific heat capacity again? Do you have any idea? What
The
is
amount
specific?
of heat energy required to increase the temperature of a given body of the unit mass of a given material by a unit temperature.
Hari. It is like the specific heat capacity. Unit mass means 1 kg. Unit mass having a temperature of theta, and you supply certain amount of heat energy. Certain amount of heat energy. We call that one as C. Okay. To raise this temperature by theta plus 1. Theta plus 1. Okay. The thing is, MC theta, C equals to Q over M delta theta. The amount of heat required to raise what? Temperature by unit degree only by 1 Kelvin. 1 Kelvin. Only by 1 Kelvin of a mass of 1 kg. So this amount is known as, again, imagine like this is gold. You take 1 kilogram of gold and you measure the initial temperature and you heat it until imagine like the temperature is like 25 degrees Celsius. You have to keep it heat until to 26 degree Kelvin Celsius, sorry. So by that time, it needs to absorb certain amount of energy to increase the bond vibration. So the thing is, it will finally gain the required temperature by 1 degree Celsius addition. So the amount of heat given is known as specific heat capacity. The unit is going to be joules. Here this measured in joules. J kg minus 1, k minus 1, or C minus 1, whatever the unit. So it is known as what? The specific heat capacity. Honey? Dagan. Definition the amount of heat required to raise temperature by unit degree of a unit mass of certain specific matter. That's differ from matter to matter. It's specific for gold, some value, iron, some another value, water, another value, regular gas, another value. So different material has different value. So that's a fact. Copy this. Shall I erase? So let's do some calculations. Not now. It is a very simple thing. Now today's lesson. We have to start the today's lesson. That's gonna be expansion of matter. Expansion of matter. Right of subtopic. Expansion of matter. Or thermal expansion. You may write. Thermal expansion. Now you understood how the temperature works in expansion. Now write this in a new line. All the objects are made out of matter. All the things are made out of matter. Things are made out of matter. Matter consists of small particles. Small particles. Maybe atoms, molecules, ions, compound, or smaller coagulated particles. Small coagulated particles. Right. Small coagulated particles. Now write this in a new line. These particles may absorb heat energy. These particles may absorb heat energy. Heat energy. May absorb heat energy. As it absorbs heat energy, you momentarily got disconnected. So what is the last thing you wrote? What is the last thing that you wrote? Just the topic. Is there anybody who wrote this thing? මට මතක නෑ මම ඔය කියන ඒවා කිසි දෙයක් ඔළුවේ තියාගෙන කියන්නේ නැහැ නේ කටපාඩමින් කියන දේවල් නෙමෙයි. සරණ ලිව්වද? Sarina.
Yes, sir.
Did you write?
Yeah, I wrote, but
අනේ read කරන්න අනේ.
objects are made out of matter. Matter consists small particles, atoms, molecules, compounds, smaller coagulated particles. These particles can absorb heat energy. That's all.
Okay, you can write it like this way. All the matter is made out of particles. All the matter is made out of particles. These particles may be all the matter made out of particles. These particles may be atoms, molecules, compounds, or coagulated small particles. And these particles may absorb heat energy. After what you have written? Yeah, man. When raining, it's really inseparable. Can you tell me what is the thing after? What is the very last bit, Sarina?
These particles can absorb heat energy. Absorbed heat energy. That's all.
Absorbed heat energy, and the absorbed heat energy cause them to vibrate faster. Cause them to vibrate faster. If it was like this, these were vibrating like this. Now, because of the absorption of heat energy, this absorbed heat energy may cause it to vibrate faster. Due to vibration, due to rapid vibration, it has to capture more space. It has to capture more space. This acquired more space, right? This acquired
Sir,
more. Huh? This acquired more space cause it to have more volume. 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 හරිද? Cause it to have more volume. හොඳයි. ලියන්න. So the expansion can be studied under, solid expansion can be studied under three different ways. Under three different ways. What are the three different ways? Write this in under one after another. Expansion of length, expansion of length, then expansion of area, lastly expansion of volume. මම length විතරක් මේ board එකේ කරන්නම්, area and volume අර board එකට යන්නම්. හානේ හරි. Now write expansion of length, expansion of thermal expansion of length. Much better writing like that way. Thermal expansion of length. Thermal. Right. Write it like this. Thermal expansion of length. Due to absorption of heat energy, as objects increase the volume, length increases too. At the beginning, you can consider it like L0. Then you apply more heat. As a result of it, it would increase the length like this manner, with an expansion of delta L, length of delta L. Okay, so you can see now this is the L0 length here. All together new length is L theta. Mark all of these, and this is like in the temperature of theta 1, and here the temperature of theta 2. Here you can see now delta L. What is delta L? Delta L is equals to L theta minus L naught. Isn't that? Delta L is equals to L theta minus L naught. So you can see now the delta L length is proportional to change of temperature. That means theta 2 minus theta 1. Right? Okay. Now I am going to put some what is delta L here? Number 1. Number 2. I am going to put what is delta L here in terms of these two terms. So it is going to be L theta minus L naught proportional to theta 2 minus theta 1. Right. You know what to do to remove any proportionality constant. How? There are two ways. One is dividing two equation sets and remove the proportionality. The other method is how? How can you remove the proportionality? What is the second way? Tell me. Hello. Hey guys. Where is it? Huh? What is the second way? Very good, little girl. Adding a constant. I'm going to add a constant. Theta 2 minus theta 1. Okay. I forgot one thing. Delta L also proportional to original length of L naught. I forgot that part. So also proportional to L naught. I forgot that part. So it is going to be L theta is equals to L naught. This L naught goes to there. L naught plus alpha L naught theta 2 minus theta 1. So I can bring the common factor out. Once you get the common factor out, L theta is equals to L naught common 1 plus alpha theta 2 minus theta 1. This is how you derive the first set of equation. If you couldn't understand, please ask me, I will explain you. Do you need me to explain or not? Hello? Lamai, do you need me to explain you or not? No special need. Okay, but if there is a somebody, ඕනද නැද්ද කියලා කියන්න ටක් ගාලා. Okay. Little girl understood? No. Okay. දැන් copy කරගන්න. අපි යමු ගිහලා ගානක් දෙයක් හදමු. දැන් මට කියන්න මම අද හවස දැම්මේ sorry theory note එක. මම එන්නත් පරක්කු වෙන නිසා කියෝ ඉන්න කියලා. ඔයාලගෙන් කී දෙනෙක් කියවද ඔක? How many of you guys just read it? කී දෙනෙක් විතර කියවද? Oh, Brindavan, very good girl. Others? How the කියුවේ? How many of you read before joining to class? Sehat boy, very good boy. And apart from them, who else? Nobody. Emad, you read. Good. Naligaman කියන්න අපි අර බෝඩ් එකට යන්න. ගිහලා සට ගාලා lemon ටිකක් හදාගෙන යන්න. හරිද? කියන්නේ ළමයි මම කරමු. කියන්නේ ගිහලා ටික් කරමු. Okay. ඔය කියන්න. හා. හරිනම් හරි ඔය කියන්නත් ගන්න. ඔය කියන්න බැරි. එහෙම බෑ ඔය බින්දා එදා කිව්වා වගේ ඔය කියලා කෑ ගන්න ඕනේ. In that day you scream like OA in the class. Can you remember? In the paper class? Brinda? බ්‍රින්දා එන පොර වගේ එදා මේ ඔය ඒ ගාලා මේ දැම්ම ලොන් එක. කොහොමද එහෙනම් දැන් ඇත්තටම කෑ ගහපියෝ ගියා. So Brinda, can you? අපේ little girl බලමු. එයා නම් හරි forward නේ. Little girl පුළුවන්ද? Karina පුළුවන්ද? බෑනේ. හරි okay. You are the little girl. Yeah. වෙන කවුරුත් ඉන්නවද little girl? All the others are 19 years old. You are the only 18. Still 18 is not completed. So you are the only child here. And also Imet is there. He is a boy. In girls wise, you are the only child. All the others are adults. Bane? Imet boy. A thermometer with hypothetical scale S degrees. සරීනත් දන්නේ නැහැ. අදලා තියෙන සරීනා සෙහත් හරි සහස් හරි තුන් දෙනා එක්ක. S not. As a lower fixed point reading freezing point of water as 20S. 0 degree Celsius equals to 20S. නොම දාගන්නකෝ. And boiling point of water as 100 degree Celsius as 160S. Find out the reading of the scale when measuring temperature of 70S. Right. Question mark. How to find it? Very easy. (70S minus 20S divided by 160S minus 20. Yeah, can you see this? So you have to get the gradient of this one. 70S minus 20S subtract divide by 160S minus 20S. This should be equals to theta minus 0 divided by 100 minus 0. So your result will be theta over 100 is equals to 50 over 140. (500 over 14), 250 over 7, How many sevens are there in 25? It is like 3. Then it is going to be 4 remaining. 40. How many sevens are there in 40? 5. So, and 5 remaining, it is going to be 7. 35.7 degree Celsius. Did you get this answer? Okay. I hope you understand. Next one, a fixed volume thermometer reads 48,000 Pascal under temperature T Kelvin, and the relevant pressure of the triple point of water is 42,000 Pascal. Right? Find out the Kelvin equivalent of T. Okay. Fixed point thermometer reads we can take it like 48,000 as the higher point, and the lower point we can consider it like 42,000. No, the higher point is not given here, no? Wait. And the triple point is going to be 4 degrees Celsius. Detail එකක් මොකක් හරි යා මෙයා වෙලා තියෙනවා. Now in the next one, the 7th one, for hypothetical scale, LFP is like lower fixed point is 120 milliampere, and the highest fixed point is plus 60, reading on the 250 Kelvin on the scale. Theta minus sorry, not like x minus lower fixed point is minus 120 over 60 minus 120. That should be equals to 350 minus 0 divided by 100 minus 0. So the answer is going to be x plus 120 over 180. So 350 over 100. Right. How to cross multiply? 10x plus 120 times 1200 is equals to 35 times 180. So now I can cancel zeros from here. X plus 120 is equals to 35 times 18. 35 times 18. Here this පහේවා 10ක් 350යි 20ක් 700යි 700 minus 70 is like 300, sorry, 630. X equals to 510. Understand? Did you get this answer? Did you get this answer, lamai?
So isn't it asking for it in Kelvin? So
Yeah, asking about scale, reading on the scale. 350 Kelvin. Oh, shit, it is in Kelvin. No? Oh my God, I made a big mistake. Yeah. I made a big mistake here. Asking about Kelvin. -77 Celsius. I made a big mistake here. Yeah, I made a big mistake because I didn't apply it to Kelvin Celsius. Yeah. (180) should be equals to 77 over 100. Can cancel 1 0 from here, cross multiplication. 10x plus 1200 equals to 77 by 18. Here I will have to use calculator here. $1,385. So I finally find an answer like 10x equals to 185. X will be 18.5. Okay, ampere. 18.5 ampere. Did you get this answer? Did you find this answer? Hello, Lamai. Did you find answer as this one? Did you find the answer as this one? Okay, ළමයි. හරිද? කොහොමද ළමයි කතා කරන්නේ නෑනේ? හරි. ඒ ලෙසන් එකට මම දුන්න ටයිම් එක හොඳටම ඇති. I gave more than enough time for that lesson. So I will rapidly explain these two. 0 degree Celsius of platinum resistance is this much. 100 Celsius mark with 14 ohm. What is the resistance for 11 ohm? 11 minus 12 divided by 14 minus 12 is equals to theta minus 0 divided by 100 minus 0. Okay. Minus 1 over 2 equals to theta over 100. Theta is equals to minus 50 degrees Celsius. Did you get this answer? Minus 50. You can go for the minus degrees as well. Now, what is the temperature Fahrenheit equivalence of 20 temperature change? Degrees temperature change. Okay, you should know one thing. The gradient here it is 180. Sorry. Over 100. X over 20. So if I just directly get it, you won't understand. The thing is, it is given like 212 is the highest point, subtract by 32. This is the grade range. X equals to, the change here is 20 degree. The range is like 100 minus 0. Then you get like the answer. X will be equals to 180 times 20 divided by 100. The exchange will be 36 Fahrenheit. Understand? Yes or no? Okay. That is enough for that lesson. I explained you this part today very earlier. So here you have to firstly study some more things in electricity. This electricity thing. Firstly, take like 5 minutes and read this and tell me whether you understand. I will exactly explain you these things in current electricity lesson. But it will take longer time for you to practice exam questions. So, to you to practice exam questions, we can't wait for one current electricity lesson to be done. So you should just do some self-research and manage these things. And finally, I will have to ask you one important thing because I just taught you this part today. Can you just start to read this page? මෙන්න මේ ටික කරන්න පුළුවන්ද කියලා බලන්න තනිය. I'm asking, can you just read this whole part and understand? I will give you 5 minutes. No, 5 minutes might not be enough. So I'll give you 8 minutes for you to do that self-study. This is about a self-study. Ms. Zarina, by the way, did you find the paper? You asked me that what is that paper? I said last week one, but I didn't send you. Did you find it? Lamaya? You asked me what is the paper? What is this cute PDF you asked?
Oh, yes, sir, I found it.
Okay. I'm starting the timer now.
How is it?
How is it, Lamai? Did you read? I just asked you to study, not just to read that all and firstly read it. Determination of specific heat capacity by electricity method. You might not really understand because you don't know Ohm's law. What is Ohm's law? What is this? But you at least tried. That's the only thing I want to know. Did you at least try to read? ළමයි කියන්නේ මොන හරි දෙයක් තේරුණාද නැද්ද try කරාද ඒත් නැතුව නිකන් මේ Instagram එකට ගිහලා පිස්සුවක් කෙලියද ඔය ටිකේ ළමයි hello try කරා huh? Don't text to that device man everybody just text to that one. I'm really sick of that. This one whenever you don't see me drop to this one. You went through it. Others? Hari. මෙහෙම කියමු. In electricity lesson, you will learn this one in detail. But we can't wait for electricity lesson to complete because we have to start to do A-level questions. During A-level question, they nearly merge heat lesson plus current electricity lesson. බබා වෙන්න දැන් බෑ ළමයියා. බබා වෙවි හිටිය ඇතිනේ දැන් බබ්බු වෙන්න බෑ. තව මාස 6කින් A-level ලියන්න ඕනේ. So you can't be the baby now. You referred to Nelson and Parker book. Very good. That's the best physics book so far. It includes everything. Even in my A level, I studied those series of books. some of the calculations are not up to date because they were like written very old, long days back now. But still the physics theories are really valid. But some of the parts are not really tallying to local syllabus, but still really valid. Very good book. Here the thing it is, when you supply certain current through a conductor, when current I flow through it, it will convert it to some kind of heat energy. The reason is the moving electrons are colliding constantly with these ones. As it collides, these particles begin to oscillate. You know that if the oscillation increases, we see it like a change of temperature. If the change of temperature occurs in certain mass of matter, so that means heat energy count increase. That is an obvious. So when current of I flow in a current carrying conductor under potential difference of V under time of t, so we can just find it out as the power is equals to Vi. This is a current electricity equation. What is it? Power. This is power. V stands for voltage or potential difference, PD, and I stands for current. මේවා මම එතනදී in detail කියනවා. Why it is කියලාත් කියනවා. But here we are not going to get it in detail. We have to learn it how to apply only. Because we can't wait for that lesson to done to do A-level questions. එතකොට අපේ කාලේ ගිහින් ඉවරයි. Time එකක් නැතුව යනවා. So we know from mechanics, power is equals to work done over time, or in other way, energy over time. So amount of energy is equals to power multiplied by time. We know what is power in terms of here. What is power? What is power? Sorry. Power equals to Vi. So the amount of energy transfer during certain time of t under some current of V under the potential of V, it is going to be VIT. Understood? ඔව්ද නැද්ද? Yes or no? Hello? Yes, understood. That's great. E stands for energy and T stands for time. මේක ළමයි ඒ පාඩම කරනකන් ඉන්න අපිට බෑ. හරි? මේක භාගයට තේරුම් අරගෙන ගාන හදාගෙන යන්න පුළුවන් වෙන්න ඕනේ. මම ඒකයි දැන් ඉඳන්ම මේ ටික කරන්නේ හීට් එකේදී ඉස්සරහට නැත්තම් සුපිරි නෑමක් නානවා. දැම්මම දුන්නේ ඒකයි ඒ ටයිම් එක වෙනකොට ඔයාලට මේක self study කරලා ready වෙලා ඉන්න පුළුවන්. නේද? කියලා කියන්නේ. එතකොට හොඳට බලන්න. V equals to IR. IVT is the amount of energy transfer. MC T delta theta. MC delta theta, we know that is the thing. And we know another thing. V equals to IR from Ohm's law. I'm going to substitute this one like in terms of I. I is in terms of what? V over R. When you substitute, it is going to be V square over T. Okay. So somehow this is the IVT, the amount of energy supply. M1 C1 theta 1, M2 C2 theta 2. That means you have to gain by liquid, gain by the calorimeter, because liquid is put in a certain calorimeter. Some amount of heat is absorbed by liquid directly, other amount is absorbed by this one. Both amounts you have to absorb by the liquid, absorbed by the calorimeter, given by this one. So one gives, many may gain, or many may contribute to give, many may gain. That's how it is. At least there should be a one donor, one receiver. So have a good look at heat energy supplied by the coil equals to heat energy gained by brass. That is the concept. One gives, at least one gain. Or two or more collectively give, only one might gain. Or two or more collectively give, and two or more collectively gain. Somehow there are givers, there are gainers. According to the law of conservation of energy, the amount of heat given equals to amount of heat gained. Can you understand? Dunna gana tamai ganna puluwa. This like you asking money from your dad. Dad might only give you like 1,000 rupee. Then you have to spend that only. එහෙම නැත්නම් හොරගම් කරන්න වෙනවා. In physics they don't do. Yeah, Sahas, that's how. I will explain you this in detail in current electricity lesson, but we can't wait. Now have a good look at heat loss should be equal to heat gain. Good thing is 250 lead 170 Celsius, it dropped into 100 gram of water at 0. හරි. මෙයා 170 ඉඳන් බහිනවා common temperature theta වලට. මෙයා බිඳුවේ ඉඳන් නගිනවා. Water gain, let loose. See? Heat loss like 0.25 kilograms. Specific heat capacity you don't know. And the temperature change is 170 to 12 because the common temperature became 12. It dropped. Water gain means 0.1 kilogram. Specific heat capacity is very high. 12 minus 0. So you have to cross multiply and find out the specific heat capacity of lead. Very simple. Now let's shall we try some of these questions? ගොඩාක් ඕනේ. අපි නිකමට මේ ලොං එක නම් පොඩ්ඩක් අමාරුයි වගේ. කමන්නේ. අපි MCQ 4 try කරමු. අර ටිකට මං උදව් කරන්නම්කෝ. Try the 4 MCQs. I will give you 8 minutes. So do you need an interval before that, or shall we just continue? පොඩි interval එකක් ඕනේද? එහෙම නැත්නම් මේ ඔහොමම continue කරනවද? කියන දෙයක් කියන්න. We don't have much time. ළමයි චූටි interval එකක් අරන් යනවද? ඔහොමම කරගෙන යනවද? සරිනා නම් ඉතින් interval ඉල්ලන්නම් බලන්න ඉන්න මිනිස්සෙන්නේ අනිත් කට්ටිය කියන්නකෝ. We can't count Sarina on this case. Battery load boru කියනවා. හරි. මං හිතනවා ඇත්ත කියලා. පොඩි ළමයි බොරු කියන්නේ නැහැ. අනිත් අය very short break එකක් ගමු එනං විනාඩි 8ක් ඇතිනේ. I started class even half an hour later. No, it's going to be 8 minutes. Interval of 8 minutes. 10 ඕනේද? හරි 10 10 10 minutes පවුනේ.